Hey guys, this is the first video. This right here, as I die, coughing, choking, whatever the heck is happening to me, is the first video for Unit 1 of Algebra 1. In case you didn't know, this entire course, the lectures at least, are available for free here on YouTube. A subscribe and a like would be appreciated to help us out with that. We're going to be talking about graphing linear equations. This entire unit is all about linear functions. So it would be helpful to know what a linear function is. So the first thing we need to know is graphically and from a picture, linear equals line, right? So when we're graphing linear functions, the way they look is they look like a line, right? So a straight line. Or a bunch of lines, right? Whatever is happening here. Okay, so they look like a straight line. Okay, that is a linear function, right? Now, from an equation, what makes it a linear function? Because that can be more useful, because a lot of times we are given an equation, given a function written out in y equals or f of x equals notation. And so a linear equation, linear function, is one in which the highest power of the x term is to the first, right? So that's a linear function right there. If I have y equals 3x plus 2, that's also linear, right? Because the highest power here is 1. We could also have 2x minus 3y equals 15. That's also a linear function. All of those are linear functions. So in order to fully understand what's going on, what are some non-examples? What are some non-linear functions? So something like y equals x squared. That's not linear because the highest power is a 2 instead of a 1, right? Or if we had y equals 1 over x. Now, that one's not, if we don't know exponent rules, and at this point in Algebra 1, we don't necessarily know how exponents work, but this is not, even though this is to the first, it's actually to the negative 1. We'll learn more about that. So this is a non-example. None of these are linear functions. This one is also not linear. If we have y equals yx, that's not a linear function because we got two variables multiplied together. So that one's also not linear. So all of those are nonlinear, and things with x to the first are linear. Y and x to the first, if you want to be technical, right? So let's kind of look at some examples of what we can do with all of that. Pardon the interruption, but I have a life outside of math. I know, that's shocking. I don't live in this little box of the YouTubes or in class or whatever else. You know, all of those things. So let's look at an example. We're going to look at an example with a linear function in it. So a linear function is often graphed on a coordinate grid like this one. You probably, at the very least, have seen how to plot points, right? If nothing else. So, excuse me. So yeah, you've probably seen how to plot points. We're going to look at how to identify the intercepts. Let me put one up here. So we're going to look at how to find the intercepts. What does that mean? Intercepts. Right? So we're talking about the x-intercept. And the y-intercept. Okay, so the x-intercept and the y-intercept, right? So the x-intercept is right here. I have children. I may have to go and tell them to be quiet. I don't know if y'all can hear that, but something is happening crazy. I hope it's fun crazy. The x-intercept is right there. The y-intercept is right there. The y-intercept is right there. So what does that mean? Well, at this point, it's probably relatively obvious. But if not, then the x-intercept is where the graph crosses the x-axis, right? Because in case you didn't know, the horizontal axis is the x-axis, right? And the vertical axis is the y-axis, right? Easy peasy, no big deal, right? So those are the axes. The x-intercept's right there, and the y-intercept is right there. So what is the x-intercept of this graph? Well, it is the point 1, 2, 3, 4, 5, 6, 7, the point 7, 0. Because remember, points go x, y, right? So x, 7 on the x, 0 on the y. All right, so what is the y-intercept? Well, it's the point 0, -2 in this case, right? Easy peasy, lemon squeezy. Let's look at one more example just to be sure that we understand what's going on. Right? And I prepared it ahead of time, so let's do it. Let's take care of it, right? So the x-intercept here is at -1, 0. You notice that it's always a 0 for the x-intercept. The y is always 0. That's going to be important for our next type of thingy-mabob. Okay, so the y-intercept is the point 0, 0 in for the x. That's going to be important in a minute. And 4 for the y, the point 0, 4. Right? That makes sense? Yes, I think it does. So let's take kind of that information and that hint and allusion to do something else. We're going to do another kind of a example. I guess those were examples. They were easy examples. So here is going to be our example. I guess it'd be 3 at this point. Sorry, I'm being distracted a little bit by the boys being crazy as they do. These things happen. So for this example, we are going to graph (2x) plus 4y equals 16 by using the intercepts. Okay, so there's our function right there, right? 2x plus 4y equals 16. So to find the x-intercept, we take and we put a 0 where the y is. And then we solve for x. Okay? So putting a 0 where the y is. And then bringing everything else down. And now we're going to solve for x. It's pretty easy at this point, right? Because 4 times 0 cancels, because 4 times 0 is 0. So we end up with 2x equals 16. And then we're going to divide both sides by 2. Those cancel, leaving us with x equals 8. So our intercept is 8, 0. So we're going to go up here and go up and down 0, right? And then we're going to go over 1, 2, 3, 4, 5, 6, 7, 8. Barely going to fit on my little grid here, right? So there's the x-intercept. I'm going to just, I don't really want to do that. I'm going to squeeze it in here. This is not best practice, but this is kind of what we're going to do. You probably want to keep your notes a little bit neater, but I'm kind of limited on space here because I want to try to keep all this in one page for you guys. So for the y-intercept, we're going to put a 0 in for x and solve for y. So 2 times 0 plus 4y equals 18. 2 times 0 cancels. So we've got 4y equals 18. Then we're going to divide both sides by 4. Well, I don't know why I'm writing 18. Like, that's not going to come out even. You can get fractions on these. That is possible, but we're not getting fractions. So how about 16? How about 16? And then 4 divided by 4. So y equals 4. So the y-intercept is the point 0, 4. So 0 up 1, 2, 3, 4. So now to graph this line, all we got to do now is connect the dots. And that's it. And then it keeps on going. I should have pulled out my ruler. That's probably, let's see. Let me aim it and see if I can get the best. Let me see. Let me see if I can get something prettier. This should go up 4 and then over all the way this way. There we go. That's gorgeous. And it's a line, so we're going to put arrows at the end, and it keeps on going. There we go. So that's pretty easy peasy, graphing that using intercepts. And that's as far as we're going to go in that video, I think. I better double check. I feel like I'm forgetting something. I am kind of leaving something, but I think I'm going to leave it because we cover it heavily in the next unit. So why waste our time now? So that's it for this video. If you're one of my students, then do your homework and get all the things done, and I'll see you in class. If you're not one of my students, thanks for joining us. This entire course, all of Algebra 1, all of the lectures at least, are available for free here on YouTube. If you could, it would really help us be able to offer that to you if you would hit that subscribe button and the like button and leave us a comment below letting us know anything else, any other questions or comments or snide remarks you might have. Thank you guys. Have a great day. Check out emberlearninglabs.com for more.